Alright, let's look at an example for Green's theorem. Alright, so let's apply the Green theorem to this integral, see if we can make our lives a little bit easier. Alright, so you have an integral, it's a line integral along the curve C, e to the x cosine of y dx minus e to the x sine of y dy. Alright, so let's see, since it's not the this is not a boundary of any region, so I'm going to add extra curve here to complete the circle sort of, complete the trip. So I'm going to add this curve. It's actually a straight line segment. I'm going to call it the C prime, right? So a combination of C and C prime will give us a boundary of a triangular region. So we're talking about this triangular region. Oops. Triangular region here. Right. So let's pretend that this is going to be the new curve. So I'm going to call this region A, just like before. Then the boundary, so boundary of A is going to be basically a combination of C and let's see, I'm going to use this notation. Alright, so a combination of those two guys. Alright, so from the Green theorem, I'm trying to identify, so this guy right here, so this is going to be P right here. And this is going to be our Q. Alright, so if we start with the integral along the boundary of A, alright, then so this is going to be P, so P dx plus actually, maybe I should be a little bit careful. I'm including the negative sign too. Q dy is going to be equal to, so this is double integral over this triangular region A, right? So this is going to be the partial of Q with respect to x. So let's take the derivative with respect to x. It's going to be still going to be exactly the same. So it's going to be negative e to the x sine of y, right? Minus, right? Then partial of p with respect to y. So it's going to be e to the x, because it's just a constant. Partial of cosine of y with respect to y would be negative sine. So it's going to be negative sine of y, right? Then with respect to x and with respect to y. Alright, but you can see that there's a nice thing going. It's actually these guys cancel out. So double integral of 0 over the region is going to be, of course, it's going to be 0. Right? So this means that if you do a line integral along the boundary of A, so it's going to be C and P dx plus Q dy, which is what we're trying to find. If you add that with the C along the C prime, so this is a straight line here segment, and the same thing, P dx plus Q dy is going to be equal to 0, right? Which means that so this is that. So this means that what we are looking for, so this is the integral we are looking for, can be found by negative of the line to go along C prime, P dx plus Q dy, right? So let's see what it looks like there. Alright, so this is going to be equal to, alright, so since it's negative, so C prime would go from negative natural log of 2 to positive natural log of 2. I'm going to incorporate this negative sign to go backward. So this is going to be an integral from positive natural log of 2 to negative natural log of 2, right? Then since this is along the x-axis, so there's no y change, so this guy is going to be 0, right? So we can ignore this guy, right? Then we have to worry about just the p, right? P is this guy up here, and note that the y is going to be 0, right? So cosine of 0 is 1, so it's going to be just the e to the x and dx, right? So this is an easy integral to evaluate. So antiderivative of e to the x is still e to the x. You are going from natural log of 2 to negative natural log of 2, right? So this is going to be, you have e to the negative natural log of 2, which is the same thing as natural log of 1/2. So it's going to be e to the natural log of 1/2 is 1/2 minus e to the natural log of 2 is 2, which gives us negative 3/2. Alright, so the value of this line integral along the curve C is going to be negative 3/2. Right? So you can see that this is actually related to the conservative field. This actually vector field is going to be conservative. So when you so if you look at this guy, it's conservative. So if you go along this path and come back, then there's as if there's no work, because the work required to get there and work required to get there would be exactly the same. If you go along here and you come back here, then they basically cancel out, so the work is going to be 0. So that's why you have a 0 there, right? But anyway, so we can use Green's theorem to make our lives a little bit easier to evaluate this integral here. All right, that's it. I hope that this was clear.